Next up, we've got a nice quick topic for you. We're going to look at power and efficiency. Efficiency should be something that you've come across before, so shouldn't be too confusing, and power is really, really straightforward. So the first thing I want you to do is just think about, what do we mean by power? Now, obviously, I'm not referring to power as in superpowers or anything like that. I have already given you the definition for this, so hopefully you're already thinking, oh, I know this has something to do with energy, and hopefully that then leads us to the fact that power is the rate of transfer of energy. So how much energy we transfer per unit time. So change in energy over change in time. So if I've got energy per time, that means the unit is going to be joules per second, which is the same as the watt. So the watt is the SI unit. Joules per second is another way that you can put it. It's not really the SI unit, and it's not quite a base unit, 'cause it's not joules is not a base one. So it's just a alternative unit that is acceptable, but watts is the more standard one. Another thing about power is it is a scalar quantity, because energy is scalar, so power has to be scalar as well. Another way that you can think about power, and this is probably the more useful one, is that power is the rate of doing work, so the rate at which work is done. So you might sometimes see the same equation of power is work done over time, or power equals change in work over change in time. And that should not come as a surprise, because we already know that energy and work mean very much the same thing in physics. I just want to raise it because you will see it written either way. You might see it as work, or you might see it as energy. And sometimes in a question they might have asked you to calculate the work in the previous bit before they ask you about the power, or they might have asked you to calculate the energy. So you just need to have that in your head, that the two are interchangeable. Now, I'm just going to show you a very useful equation. If you can memorise this, it will be very helpful. I don't think it's in the data book this year, but it is a very, very handy little thing to have. So we've already got the idea that power is work, the amount of work divided by the time. We already know that work is equal to force times the displacement in the direction of the force. So if I substitute this equation for work into the one for power, that gives me that power equals force times displacement over time. Now, hopefully you instantly go, displacement over time, that's velocity. So if I then substitute this back in, that gives me that power is equal to force times velocity. So this can be a really useful shortcut in a lot of situations. They're often useful in questions about cars. So if you know that the engine is producing a driving force of 10,000 newtons and the car is travelling at 40 meters per second, what is the power of the car? Well, you can just do the force times the velocity. You can go the long way around the houses and find all the other bits to get there, or you can just remember power is force times velocity. That's a useful one to try and remember. Okay, last thing we need to do is talk about energy efficiency. Energy efficiency is just a measure of how usefully the energy supplied is used by a device. So we tend to say efficiency is equal to the useful energy transferred divided by the total energy supplied. As a note, efficiency can never be greater than 1, because that's the maximum, because if all the energy transferred is equal to the energy supplied, so if all the energy I put in is used usefully, that would give me 1, and I can't use more than I put in. Note, this is efficiency, not percentage efficiency. If you are asked for percentage efficiency, then we just multiply by 100. But if you just asked for efficiency, I would expect it to be a decimal. Just a little thing people sometimes make mistakes on. Normally, they don't punish you for it in the exam, or they haven't historically, but who knows with the new syllabus and everything. So may as well just get it right and just give them what they ask for. Okay. So other ways you can think about efficiency is we could think about it as being the useful work that we get out divided by the energy supplied, or we could think about it in terms of power. So it's the useful power I get out divided by the power that I put in. That'll give me efficiency as well. And as I said before, if I want percentage efficiency, I just take the efficiency and multiply it by 100. And that is it. Nice and short, only just over a 5-minute video. Nice and simple, easy one for you after your horrific test, I know. So that's it. If you've got any questions, just ask when you see me.